And we were working on this problem with how high in $1 bills, how high would, if we stack $1 bills, how high would the national debt reach above the earth? Okay, so what was very telling about the way the student was approaching this problem and our subsequent conversation was that she was kind of just looking at the numbers and kind of looking for a method to get an answer. She was very focused on maybe doing some kind of calculation to get an answer. And of course, that's involved. So I diverted her and we started having a conversation, and the light bulb started going off with her that when we had this conversation, it was all about her image and conception of the situation. That she was totally going to forego that just to calculate something to get an answer, when what was so helpful to her was, as I guided her to get a powerful image of her own of what was going on in the situation. That included a picture, and it included identifying the main quantities involved. Okay, and we hadn't even talked about any calculations. We didn't talk about any methods, procedures, anything like that. And you could just see her face like, oh, so it was like we took this time to understand the situation, understand the question, and then with a picture and by focusing on the quantities, and then we had the quantities, and she set up the relationship, and it was like now the problem was done. Like so she had that relationship with the quantities, and boom, it was like so easy for her to finish. So I just want to, this idea of what do I do with the information given to get an answer is an epidemic in our country. Have you guys read The Teaching Gap? Or will you? Some of you? I think there's a class that you'll have that you'll read The Teaching Gap. And it's just emphasizing this point that there's such a procedural answer. And we talked about that with the first article, right? First article. So what's the alternative? Given us a real world situation, do you have a full grasp of it? Do you have a full grasp of it? And are you focusing on the right quantities involved? Okay, so let's do that. So I'm going to show you this animation I made. Here's this for 8. And so I have the car starting here. And then if I start the end slider, so it's like we pause time. It was actually 3 hours. 3 hours into the trip is where I showed you starting. And then I let n increase, and n is the number of hours. Okay, n is the number of hours, and as the hours go by, we make progress to our surfing destination, okay? All right? Gotta have a surfboard, right? Okay, so my task for you is, I want you to identify the key quantities. So n is time. You can't really draw time, but you can draw all the distance-related quantities in the situation. So it said, what did it say? X was, no. All right, so for those of you, there's a way to just have the slider just play forward and then start over, which I did not do. I should have done. But for Mac, it's Option. You hold on Option when you hit play. So I'll do that again. I put all these things at the bottom of the command line, and it messes it up. Okay, so yeah, if you hit Option when you push play, then it'll start the end slider over. Has anyone discovered on PC how you do that? Control.
I don't know, I'm not sure.
It's something like Control. Yeah, maybe Control play. Does it work? Okay, so try Control play. If not, maybe I don't know, something else, some other one of those types of buttons. But I'm pretty sure Control play will do it. Okay, so anyway, so what did I say? I said that we're gonna think of a situation where okay, so think of a situation where we're kind of thinking about 3 hours in, starting from 3 hours in, and we're going to go from there. And so given that setup of that problem, can we focus on or identify and then finish this picture so that it's focusing on the important distance quantities involved and the variables that were given in that homework. So you're going to make this picture so far, and if you make a straight line, that's fine. I'm making a little some convoluted sine function to get a little wavy road there. Okay, but you can just draw a straight line. So you can start with this, and what I'm asking you to draw is starting from 3 hours and thinking about the car continuing its journey. What would the relative variables be for all the distance quantities, and can you show those in a picture? See what you come up with. Is the task clear? So I want you to define and label the relative distance quantities relative to the variable y that was given in the problem. So how was y given in the problem? What did it say? The variable y was?
Your distance from LA.
Your distance from LA. Okay? So starting from 3 hours in, we want to look at continuing the journey and tracking quantities related to y, the distance from LA. So let's draw a picture. So let me clarify. So the fact that I'm starting from 3 hours is important, but you can't do it. You can't do an animation on your paper. So what you're going to want to do is do a snapshot for some time later. So when you draw it, it's going to be you're going to freeze time sometime after 3 hours. Does that make sense? And then you're going to make your picture based on that. So you're going to make your picture based on starting from 3 hours into the trip, and then some arbitrary later time after 3 hours. Okay. So then, what are all the quantities related to y that are important? Okay. Does that help?
So we're drawing on a piece of paper.
Yes. You're going to add to this. You're going to add to this picture to visually define the variables or constants or whatever related to y.
So I drew the other
Yeah, because this is for change, and going forward, that's your change of x, and then, so basically, from measuring that part, change in x, but the part
So yeah, of course.
so they're all the same.
Yeah.
So no, because this is all like your change. It's just your change.
This is the first picture.
What is x? Good conversation. Very good conversation. But what's x?
Oh, so we
Right, so it's first.
so you would start at
Okay, yeah, that's 5 hours from yeah.
starting you would start from 3 hours.
Yeah.
So you can drive here and
It's kind of ugly.
See, but see, this portion doesn't really matter.
Here.
It's
So remember, we're looking at the specific situation starting from 3 hours,
from your car to
and then
so it's the second
time is going to increase starting from 3 hours. So what's all
so
the
as you got
relevant
closer.
distance?
So it's basically from whatever specific segment we had.
3 hours is where the car is. When I get 3 hours is where, because you know how when his animation started, it was 1 minute.
And I tried to explain it to you.
Oh, that's the name.
Fire away.
I'm trying to think if there's a way to
Don't worry, you're being
So then,
But anyways, don't worry about that. So what I'm trying to say is, so we mentioned that this is where to LA is how many miles left? So as you get closer, your change in Y essentially becomes this much.
What about the 3 hours?
that's probably what it is with 5.
That's important, the fact that we're looking at the particular situation starting from 3 hours. Starting from X equals 3 hours. That's part of it. That's part of the deal.
There are other things we can write.
So when you drive,
So that's why it's
time.
it's in.
Subtracting.
So why? So let's say you drove, right?
Yeah, so however many hours. So kind of like my DX.
No, because this is taking this right here. This is
What is X in this situation? What is X?
yeah. So here, this is hours. So it decreases over time. So. Wait, so if they go X hours, so
You guys are making good progress. Keep
so then if we go to
What is X?
it's
Time. You can't draw time. Yeah, this is all these. Everything should relate to Y because X is time. Yeah, so
okay, so then you are right. You are right. I'm sorry.
you're right. It's progress. Actually, someone has it.
Why is the whole
I mean, like, when you draw another line,
If your car broke in like 2 to 3 hours, your DY would be 1 hour and 18. Or sorry, 1 hour and 57.
but then why is it saying that distance that the car drives by?
No, why is it?
If you draw it,
Oh yeah, sorry. But it's based off the
Oh yeah, it's just here, like 3 hours.
miles per hour. But yeah, you
Okay,
just have to watch it.
rest of you are making good progress.
are you looking for a unit Y over hour for a separate car to do?
No, so time. You can't put a bar to indicate time. So this is the distance quantities.
Oh,
So
D Y don't.
So basically, on the
You don't even need to bother.
No, I just want you to define distance quantities. Define
Or
distance
maybe we
quantities
do
related to Y.
because you said different.
but yeah, you're right.
Okay, so let me give you a little more guidance here.
That's fine.
So we don't care about this.
So lots of you had this or something close to this. Illustrate.
Because it's the bar.
When you go like
You don't care about what happened.
this is just this is where I got that. I think it's working on this thing because he has
Yeah, that's how it's
doesn't matter what you want to be.
But if you're told
So what you will
that
draw
C equals 50,
is like a snapshot, like right now. So like you can't draw it changing, so you can just draw a snapshot just like this. You're identifying these distances relative to y, relative to the way y is defined.
Yeah. Your distance from LA is increasing by 1
Okay,
centimeter.
so what is y?
So that would mean that your distance from LA is
So the whole black thing
but your distance from LA is decreasing by 1 centimeter. Calculate just y when we whatever the
Yeah,
when you show that and in order to see the so that's why it should yeah.
It should be.
Well, it's easier when you roll it on
anyways.
Whoa!
First day I was
Singular value. This is a very
We can do that. If
after every hour we drive, we go this far. I was like, no.
we do, but I said no. Hey, okay, no problem.
So if time.
So anyone want me to check to see? So now I'm showing you that there's 3 relative distance quantities, and so all relative to this variable y, and they're all things we've talked about in this class. So, and if you want me to check to see, I'm going to reveal in a second, but if you want me to check to see, you got it. I'm not showing. So okay, this is Phoenix, but that's not. We have defined that, right? That's not. So that's not one of the variables.
Yeah.
Depending on where
Right, total
This is
distance
your
traveled, is
distance
that
from
right?
LA.
Total
This is
distance
your
traveled?
this is the starting.
because it's D1.
So this is
That's not how it's defined. That's not. You're changing the meaning of y. In the problem, y was defined as well.
Oh,
Distance from LA. Still distance from LA.
So top is Y.
I was looking at another way. That's what I thought. Is it not? Why final? Does it make the distance? I know because it's final add-on there 0 miles.
DY is negative.
and when you start one then every 3 hours. So our initial distance was
See that in this illustration, what's y is the distance from LA?
well, yeah, I have y in because then y, I made y.
Oh, talking about her hair.
But I mean, like, it's
Not the gender. Ask her to take out mine.
you can tell me about
I thought it was a coupon.
That's the value of y. What is y? And what is y in this situation?
It's this.
Actually,
It's minus
This is variable distance from LA. Right?
Oh.
Variable distance from LA.
okay, we're gonna see the other one like now. And I'll work on the next one.
Okay, so we've been at this over 15 minutes. Okay, so what's the takeaway? We've been arguing and debating and thinking about this, thinking hard about it, right? What's the takeaway? So it's the point I was making before that it's crucially important to have a solid image of the situation you're looking at. And so a picture is critically important. And so y was defined. Y is one of these three. Which is it? The distance from LA. Is that constant or changing? Changing. That's not what I wanted. There we go. That's what I want. Okay. And so then what is the pink bar? dy. And what is the blue bar? Y initial. So when you were working on this problem for homework, did you have this kind of conception of the situation? Okay, if you're nodding, that's great. Yeah, so maybe you did. I'm not saying that, but I'm guessing that there was maybe some that didn't. You didn't really have a clear perception of what's happening here. And so tell me about y and dy. So anyone comment? So let's talk about now what's happening with these variables. What could you say about y and dy? Yeah, Morgan.
Yeah, add to y.
Okay, it's true. Y plus dy is y initial. Okay. Actually not. They don't. They do not add to the y initial. Yeah, that's a good question. Why don't you discuss that? They don't add. Y plus dy is not y initial.
Well, why?
Right? You need to talk about this and get this. This is important. What's going on with y and dy? And why is y plus dy not equal to y initial? It never has been in the past, so it's not in this problem either. You don't add y plus a change in y to get y initial. That doesn't make sense. Okay, so figure it out. So to really make sense of this, you got to answer my initial question. What's going on with y and dy? What is going on with y and dy? That's the question.
I think when you said
Because if it's 3 hours, that's 5 miles away, and then a couple hours after that, 300 miles away. It's a decrease in from LA.
Okay, or just very simply, what's going on with y? What's going on with y? Decreasing. Therefore, dy is negative. dy is negative. Okay? So I'm expressing it as I'm expressing on the screen as distance, but its value is negative. Okay? So you could think of, if I pause this at any particular point, you could think of that value of y as y final. Is y initial equal to y final plus dy? That's kind of, if you're thinking that you're just going to add those two up to get that one, that's what you're saying. You're saying y initial equals y final plus dy. Is it right? What is it? Is that right? Forget about this problem. Is that right? Yes. Now make sense of it in this problem. This is right. Now make sense of it in this problem.
Because if you change your y to LA, then this 2LA as I grab 2LA is a decrease. So you're in this problem,
Well, this.
yeah, but he said every time he follows so the black is the y final. Black is
No, we'd love to see it. I just like did an arbitrary distance of like 10 miles.
Okay. Any questions? Does it make sense? Did you hammer that out at your tables? So someone well, why is this correct in the given situation? Why is this correct? Anyone volunteer to say that? I mean, this is always true for all quantities. That the final value of the quantity is the initial value plus the change in y. We talked about that in last class, right? So how does it make sense in this situation? Can you articulate it? Morgan, brave one. Oh, brave one. Yes, go.
So since dy is negative,
right,
and we're changing negatively, then we have to. So the picture threw me off because they combine to equal, like their lengths are the same, but their values are different than that. So where you end up is always going to be where you started plus where you went. So
okay.
The y final is the y initial plus the dy.
Okay. Others want to chime in? How does this make sense for our situation? Don't be afraid. Saying, were you about to say something or no?
I thought it's like you say if that line is true, so to the right the positive is the positive, I guess, the direction. So the dy is decreasing to the if the dy is increasing to the left, so it means that it's decreasing. Right. So dy is increasing to the left, so it's decreasing or negative.
Yeah, I guess so. Yeah, so I guess positive values of y, right? So positive values of y are to the right.
Mm-hmm.
So because our y would be 0 for y, and positive y extends this way, and so then as dy extends to the left, it's a negative change. Okay, yeah, that's good. That's good. Yeah.
Well, you know how I thought of it was because to find our change in y,
Uh-huh.
you have to subtract. It's y final minus y initial.
Right.
So in order to find your y. You can find y initial, but that's not the correct formula. It's actually y final minus dy once you do all the rearranging. So what you crossed out up there, it would be fine if it was minus dy, not plus dy.
Okay.
And so to find our final, it's essentially the same as well. You just basically add y initial to the other side. So I just did it based off of the dy equation of y final minus y initial.
Okay, so then why does that make sense here? So why does dy equals y final minus y initial? How does it all make sense? Yes, that's always true too for any quantity, that the change in y will be the final value of the quantity minus the initial. How does it make sense in the picture? Yeah, Shayna.
Okay, so y is decreasing, so it's becoming a smaller and smaller number, and y initial is this set positive value, and if we're adding negatives to it, that's going to create a smaller number, which y is getting smaller.
Oh, you started off great. The end was, so you said so it's, y is decreasing, right?
Mm-hmm.
So how does y final, the value of y, compare to y initial?
Smaller. Yeah, it's
Smaller.
So
Therefore,
So you're end up with
subtract to
I was
get
talking
it.
about the top one. It's why I thought that.
Oh, you're talking about this.
Yeah.
Oh, okay. Someone else had their hand up. Okay, so what? X is increasing, right? And what happens to y as x increases? Decreasing, right? And that's so. Now I'm showing you some more of the code here. Just that this is tracking the x and the current values of x and y. Okay. So the question is, and now I'm going to show you dx and dy. So dx increasing or decreasing? Change in time is increasing, and so you see dy here. So is that consistent with what we talked about? Dy is negative and getting more negative, right? It's a bigger and bigger negative change, okay? So now looking at these values, is y changing at a constant rate with respect to x? Is y changing at a constant rate with respect to x? Do you want to talk about it at your tables? Say it. Is y changing at a constant rate with respect to x?
I want to put that again, just to be sure.
We said what value? Numerical value.
No. The change between the two.
65 was the other problem.
Yeah.
Oh, wait, no, because you have a 372.
You got this picture, by the way. You were the first one.
Now that I think about it,
Yeah, you nailed it.
Oh,
Yeah, you did really good. The first task, yeah. Okay, what's the consensus?
No.
Oh, some no's and some yeses? All right, let me give you more food for thought here. So I'm going to show you, so as x and y change together, I'm going to show you the ratio of y to x. So this is the current ratio of y to x. So I ask you again, and you can confer, is y changing at a constant rate with respect to x? Go. Is y changing at a constant rate with respect to x?
Yeah, we need to switch to our side.
I know.
X is bigger, nothing is smaller, even if it's right. That's we're not keeping a constant rate because one is decreasing and one is increasing.
No, I switched to your guys'. They were right the whole time. It's just, we still pull out positive.
Okay, I want to hear from some tables now. So how about this table right here? What did you guys talk about? This is Sam and Angela and Camry and Singh. What do you think? Is y changing a constant rate with respect to x? Not really sure. Okay. So can you speak more? Like what was your conversation like? Can you? Anybody?
Okay, so we were confused. We weren't sure what the ratio was showing us. I think is why we were confused.
The ratio of y to x.
Yes. So we weren't sure how that could show us if it's constant.
Okay. So what's the relevance of y over x for this question? That's what you were grappling with. Yes?
Yeah.
Okay. Another table. How about this? You guys check. Tamisha, Shayna, Shanley, Ben, and Joey. Nailed it. Joey, go ahead.
Okay. Okay. Anyways, like I was just thinking, like if you put x on the other side, it would be y equals and then a changing number x.
Okay.
And it's
So it can.
constantly changing, so I don't think it's a constant rate. But
So
the only thing I was confused about is because it is the number is going down at a constant rate, though. Yeah, that's how I looked at it.
and what I'm showing you is that it's not constant.
Yeah.
And this is part of the question, right? Remember, it asks you, does y equal kx?
Well, it's primarily because y is decreasing and x is increasing.
Right.
So if you were to show that, that's why it's going down, is because they're not like directly.
Yeah.
They're not related to each other as far as constant rate goes.
Okay. How about this table up here? Lauren, what did you guys talk about?
I mean, we were saying that since y represents the distance from LA and
Uh-huh.
the total distance traveled,
Okay.
that's why it's not constant, because it does tell us that it's traveling at a constant rate of 57 miles per hour, but that's relating the total distance traveled to the time, whereas this is relating how far he is, which, like they were saying, is negative, or
Okay.
decreasing as time is increasing.
So the distance from Phoenix with respect to time is changing at a constant rate, but the distance to LA with respect to time is not
The
changing at a constant
distance
rate.
from Phoenix with respect to time is constant.
Yeah. But the distance to LA with respect to time is not. Is that you agree with that? Oscar, you agree? Chloe? Everyone?
Yeah.
So y is not changing at constant rate with respect to x. Okay.
I know.
Lock. Same question. Is y changing at a constant rate with respect to x? So this is a quotient. I have created a division problem of the value of dy divided by the current value of dx. This is division. It's not this single thing of derivative, right? It's truly dy divided by dx as they take on these values. Go. Is y changing at a constant? Same question. Is y changing at a constant rate with respect to x? Were you saying yes all along? Okay. Sorry, should have had you speak up.
No, because I explained why the
Okay. Let's see. Anyone dying to chime in? Anyone dying to?
There's one point in time where
How about?
57.
Yes. Fern, what did your table say? What do you think?
That's the big point I'm missing.
Well, so the change in y is changing at a constant rate with respect to the change of x.
Okay. So what about this m? M is constant, negative 57. So just to repeat what you said, so what you're saying is that the change in y is changing at a constant rate with the change in x, but y is not changing at a constant rate with respect to x. Does everyone agree with that?
Yeah.
Yes? Chloe, yes?
Well, it seems like the distance from LA is decreasing at a constant rate.
The distance from LA is decreasing at a constant rate. So is that y and x or dy and dx?
Well, I would say that both of those are constant. Like the change, so the y equals kx, like that's not how you would represent the distance from LA, but it is decreasing at a constant rate. Because the y over x doesn't have any, it doesn't really mean anything in relation to the constant rate of change, it's just about a distance over a time.
So I think you're answering this question as yes, that y is changing.
Yes.
That's where you're going with this. Y is changing at a constant rate with respect to x. She says yes. Joey?
I feel like the only way for y to change at a constant rate of x is either y obviously needs to be the distance from Phoenix to your car, or x needs to be the time remaining in your trip
Okay.
from your car to LA.
Okay, so either we need to be looking at the distance from Phoenix or the time remaining, and then we'd have constant rate change, but this is not.
Because currently y and x are completely two different equations. They're not even the same.
Yeah, they're not even on the
They
same
have different
side. They're with
reference
respect
points.
to different parts of the trip.
Okay? Any more comments? Lauren?
So on like the homework when it said dy equals mdx, true statement, it kind of depends on how you define m, right? Because if you say m is 57, then that's not true. But if you define m as negative 57,
It just said that you were going 57 miles per hour, and it defined y as the distance from LA.
right? I mean, the problem doesn't define m, but if you were defining m on your paper,
Yeah, if you defined m as positive 57, it would not be consistent with the way the variables are defined. It wouldn't be right. You can't define it as positive 57 because y is decreasing.
right?
So it can't. Y is decreasing and x is increasing. So m cannot be positive.
Right.
If those are those quantities are distance from LA and time elapsed. Yeah.
What if you put positive 57, but you included an initial distance, or the total distance from Phoenix to LA, use that number minus your.
I don't know. I don't really understand. We have to look it up there. Okay, so you can open up a second graphing window by using apostrophes on the x's and the y's. So it's not prime like derivative, but if you do x apostrophes, I'm going to try. I've never done it on this file. But I want to continue the conversation. So I'm going to try here. So I want to show in a second separate graphing window. So that means I want to do x prime or x apostrophe and y apostrophe. Again, this is just all that's doing is indicating. I hope this works. Whenever you use x apostrophe and y apostrophe, it means open up a second window pane for a second graph. Okay, it's nothing to do with derivative. Okay, so and I want that to be equal to the values of x. So I just want to plot this point as n changes or as x changes. I just want to plot it over here. I hope this works. Cross your fingers. Okay, so there's our, still got that. So now, what are our x values? X values look good, so we just need to zoom out on the y. And we should see a, what, it has a bad color here. Black. There we go. So now I'm going to graph x on the x-axis and y on the y-axis. Okay, and now I'm going to show you that. So this is the value of x, time elapsed, and then this is y is distance from LA. I don't know if it's. There we go. So we really need to see the set of all these points. Okay, we really need to see the set of all these points. What will the set of all these points be? So let's figure that out here. So let's start with a. It's going backwards now. All right. So let's start right here. So this point is 3.6, comma 246. So what I'm about to do is really important for what's coming up. I'm actually gonna build this equation of all these points using the stuff we've done so far, rather than just a kind of sterile mx plus b kind of thing. So 3.6, 246 is our starting value. Okay, and I want somewhere along the way here. So I'll just highlight that. So what are they? 3.6 is what I want. 3.6. Okay. So what I want is I'm going to consider this to be every arbitrary point that as x increases, we get all these points, right? For different values of x. So I want this to be just not at 5 point something, but just any point. And we'll call it xy. So that second point that I drew over there just represents every possible ordered pair of values of x and y taken together. Okay, so what is this right here? What does that represent? Dx. And how can I write what that is? But I can define that, given what I have. Dx equals?
X minus 3.6.
Final minus initial, x minus 3.6. Okay, and what is this right here? Oh, I don't want to do that. I gotta stick with that terrible line. Okay, so no, that's okay. I can do that. All right. Sometimes a little OCD with these pictures. All right. Okay. So that is what? Now, rather than do y final minus y initial, we know how dy is related to dx, right? Equals negative 57 m times dx, which is x minus 3.6. Okay. So we're still grappling with, is y changing at a constant rate with respect to x? But we know for sure that dy equals this constant times dx, right? We know that, okay? So that we can use that. And then now this y coordinate right here. What does this y coordinate equal relative to what we had before? So, sing. 2, right. Y initial plus what? Change in y. Y initial is 246 plus negative 57. So my experience in the past with this class and the methods class is that students can follow along with me really easily when I do this process, but when I ask them to do it, they can't do it. They just can't do it. It's really important. So whatever it's going to take, whatever mode you have to get in your brain, whether that's writing, thinking a different way, you got to learn this because this is really crucial, okay? So yeah, you can follow along with me and answer my questions correctly, but then if I give you a piece of paper with a new situation, can you do it? All right? So what I just did was what? I just made a relationship of every correspondence point of y and x. Do you see that? Because x and y is an arbitrary point. It represents every point that we get when we change x. Right? It's every point that we get when we change x. It's all these points. Okay, so question. Is there a question? So what? dx comes first. X minus 3.6. dy is m times the change in x. So negative 57 times x minus 3.6. And then to write that final value of y would be y initial plus the change in y. So 246 plus that change in y, negative 57 minus 3.6. Everyone good? Okay, so glad that worked. Okay, so what are we going to do? We're going to do y equals 246 plus negative 57 times x minus 3.6. Since I did it red, let's do it red. Oh, but I need apostrophes if I wanted to graph over there. So apostrophe y, and apostrophe with x. No, just two. So what is this representing? Every single point, every single correspondence point of time since leaving Phoenix and distance from LA. And if we want to, we could just say y from what? Looks like I'm showing that an 8-hour trip. So 0 is less than or equal to x apostrophe less than or equal to 8-ish. If it's not 8, it's close. So the red line is, so it's a line. It's a line, and that equation, that line represents every ordered pair, x and y, that make that equation true. 246 plus negative 57, x minus 3.6. So I ask you again. Is y changing at a constant rate with respect to x? Talk. Talk. Is it y? And if no, why not? If yes, why? Go.
So for every minute x changes per hour.
There's that, you have to account for like subtracting.
So for every change,
Like the actual value.
so y is going to change.
The change is actually time.
No, this one's got lines.
Why we're asking that one? Is there how do you determine something? It's exactly.
So they are true because the line is virgin. Means how do you find one? I mean, yes. So now that's because what's the information we answered that it is because it's a changing out of relationship base. When it says changing, we're talking about
We're starting at yeah.
so now that you've grabbed it out.
I don't think we should do anything with the ratios from y to x. We determine small. It's like we're talking about the y-intercept.
That's just the nature of life. But like,
It's almost like you're going down.
No.
yeah.
For what?
Okay. Who have we not heard from yet? How about Ryan? What do you think? Is y changing at a constant rate with respect to x?
Yes.
Why? WHY. Why?
Because there's just a constant variable such that the change in y is always that constant multiple times the change in x.
So say it again. It's constant rate because?
There exists a constant multiple such that the change in y is always that constant multiple times.
So y being related as the constant rate relationship to x means that dy is a constant multiple of dx.
Yeah.
But y doesn't have to be a constant multiple of x. Let's see, what do we think? Who else is not? Jordan, what are your thoughts about this? Okay, still not sure. Not sure if it's changing the constant rate or not. Ben?
No.
It's not. Why not?
But once you get down to dy, it is.
So y is not changing the constant rate with respect to x. Lauren?
For something for y to be changing at a constant rate with respect to x, there needs to be some constant rate of change. I think that's why everyone's confused. There needs to be constant rate of change. Find a constant rate of change, we do dy over dx, not y over x.
Okay.
So in this case, any value from our function y over x, that's not necessarily going to be a constant ratio.
Okay.
But the changes are still in a constant ratio, so therefore we have a constant rate of change.
Which is what? What is the constant rate of change?
Negative 57.
Negative 57.
So for any change in the number of hours elapsed, the change in the distance traveled is negative 57 times the change in time.
So. Yeah.
Okay, so I went to the bathroom and I was thinking about
Best place to think.
So, in a different context, if you were to put ages on the x-axis and ages on the y, so like an older person, so your age on the y-axis, my age on the x-axis.
Okay.
If I was 3.6 years old, you're 246 years old. The proportion between these two numbers is going to have a different proportion to where that x and y is, but our ages would still be changing at a constant rate throughout life. They'd still be so many years apart.
Okay.
Does
So
that
you're
make
you're arguing for yes, y is constantly changing with respect to x.
yes.
Yeah. Okay. Because your age would always be the other person's age plus a number.
Correct.
So y or x wouldn't be the same, but dy or dx would always be 1. Right?
In that case, yes.
Yeah. One person's age would always be the other person's age plus some constant difference. And so your rate of change with respect to each other is 1. Yeah. Okay, yeah, so let me just... Did we go through this slide? And we said that 70 miles per hour means any additional time means the distance is 70 times that change in time.
Yeah.
And so what were we saying? Were we saying that dy is changing the constant rate with respect to x? Or just y is changing at a constant rate with respect to x? Is the distance changing at a constant rate with respect to time? Yes, that's y and x. That's y and x. The distance traveled is changing at a constant rate with respect to time. How do we know that? Because dy equals a constant times dx. You see? So, when y does not equal a constant multiple of x, like in this example, but dy is a constant multiple of dx, you have constant rate of change of y and x, because constant rate of change of y and x is about a relationship of the changes of those variables. It's not about this relationship of the variables themselves. It's about a relationship of the changes that are proportional. So what is true? Y equals kx. Say it louder. Plus b. Are y and x in a constant rate of change relationship if y equals kx plus b? Yes. It's a linear function. They're in a constant rate of change. The constant rate of change is negative 57. So what's proportional? The changes are proportional tells you that the variables, that the quantities themselves are in constant rate. So this doesn't have to be true. Okay. So again, so it's been about an hour we've been discussing this problem. And so there's the big point I'm trying to make, other than the mathematics that we talked about is really important, but another important point is that given a real world situation, there's so much to think about to really understand it well. Okay? You guys grappled, you struggled, you disagreed, and to really understand this fully, what's going on, it took time, right? And so we want to encourage our students to have that kind of mentality, that rather than procedures to get an answer as quick as I can so I can move on to the next problem or the next class, we really want to understand the situation. Okay, but now we want to practice this different way of thinking of a linear function. So this is a totally different animal than y equals mx plus b. I mean, yes, I can do some algebra here and get that form. But how is this what we did in red there in terms of building that and what its meanings? It's totally different than kind of y equals mx plus b. How is it different? So this...
Because you can use any point to compare to the y and x binary point instead of just using the y and z.
As a starting point? Or wait, say again.
The starting point.
You can start...
Point 3.6.
Okay.
You can use that or any other starting point if you want to.
Good. Right. So you can start with any known point in your relationship, and that was this 3.6246, and it will work. It'll generate the same set of points. What else is different about it? Yeah, Shane.
So basically, we're using our change in y and our change in x, but our y final and x final are just going to be arbitrary x and y.
Okay.
So when we do, so we're basically doing dy equals m dx, but with our y final and y initial.
Right. So yeah. So this is the big point. She got it. To build this, it uses constant rate of change. Right? Constant croc. See, it's not a croc, but it's constant rate of change. Okay. So what do? It was all based on the fact that dy was m dx. This part right here, right? The change in y is a constant multiple of the change in x, and then we used y final equals y initial plus the change in y. So built into this expression is all this meaning of constant rate of change, that dy equals m dx, and the final value of y equals initial plus the change in y. Okay. And then we see the particular point that we started from, and what else do we see? The constant rate. So this is loaded with all kinds of meaning and dependent on our understandings, okay? So let's use the laptop battery, and let's have you practice doing the same thing with the laptop battery. Any more questions about this? The car problem. Okay, cool. So laptop battery. So same thing. We want to express a relationship of all possible values of time since class started and what percent of battery remaining. Okay, so before we do that, I want to point out that no, I don't need to do that. Forget it. Let's see. Okay, so we're going to use that. Everyone's going to use that same initial point, which was 3541.
Yeah.
35 minutes into class, 41% battery. We're going to call this point XY, or I guess it would be TP in this case. Time it. So now, what does that point represent? It represents all the points you get when you change this, right? It represents all these, that TP that I drew, it could be any one of these points. So because it's any one, it represents all. It represents them all. And so then what we get, and what is our goal? Our goal is to write, what does P equal? So in the end, we want to get what P equals, but not by memorizing what I did and just plugging in numbers, but by starting from scratch. I'm going to start from scratch, start from 3541, and go through that process of using constant rate of change to get this relationship between P and T. So let's have you all individually try to do it, and then maybe in a couple minutes, 2 or 3 minutes, then you can start collaborating and seeing how it goes, okay? So once you've done as much as you can do, you're either going to collaborate or check your answer with someone else. But do as much as you can do by yourself, and then collaborate or check.
Yeah, so I just
remember 41 because it was in
And I was like,
Okay, who has never done this before but wants to volunteer to show me through it? Has anyone never done this before today? Something like this? It's okay if you haven't. It's not a common thing that's taught. Really, everyone's done this before. This process of developing the equation of the line. Right. So has anyone not before today done this? That's okay. You've all done it this way. Really. But you built it up from scratch before?
Yeah.
Okay, all right. Well, anyway, so Laura, can you help me with it? What do I do first?
So to find your dx.
Okay, dt.
Dt, my bad.
That's right.
Dt.
Is?
Oh yeah. So it'd be t minus 35.
She wants dt to start. dt is t minus 35.
Yeah.
No matter what t is, the change in t will be t minus 35 if 35 is a reference point. Okay, keep going. Doing good.
And then you want to find your dp.
dp.
And that would be n.
Okay.
Times your dt, which is t minus 35.
And we had figured that out last time. Which was what is m? Negative 325. Is that what it was? Okay. Awesome. Keep going.
And then P equals 41 minus dp.
And dp is, well, it's plus dp, right? So we want plus dp.
Yes.
Okay, so if I graph that, questions on that? Is that what everyone else did? So if I do y equals 41 plus negative 0.325 times x minus 35. Okay, so there's going to, so for Tuesday you have the critical précis assignment, and then a short to practice or apply this. There'll be a short GC assignment that will apply what we learned about this point slope version of a line. Yeah, point slope version of a line.
Just GC or like a master?
No, just GC. You're creating a GC file.